show. I know it's an early morning start, so we really appreciate everyone turning up, but I think you'll get a lot from a lot of the presentations today. My name's Peter Austin. I'm based here in Sydney for M2M Connectivity. Look after sales for the New South Wales ACT region, as does my colleague here, Barry Mitchell. Morning. So M2M Connectivity, our head office is based in Melbourne, so our technical staff are all there. Daryl up the end there, one of the owners of the business, based there as well. Our stock, we warehouse all our stock and whatnot. So M2M Connectivity, we've worked with a lot of people here before, so you probably know about our business, but for those who don't, we're a specialist distributor for communications technology, so covering cellular, satellite, short-range RF, and even some sensor technology. M2M Connectivity's been around for 16 years, so we've got a lot of experience there in this sort of area, and also we sort of keep on top of the technologies. If we look today's LPWAN, it's not something that's just fixed and static. It's moving all the time, so it's a matter of keeping up with the technology. And I think today is about sort of clarifying what some of that technology is, how it suits different applications. So there's a bit of an error on this slide. I apologise. This is from our Melbourne event. So these are some of the technology we're going to be discussing today. So with cellular, Sigfox and LoRaWAN. We've actually got Curling, not Microchip, here to discuss that. So we'll just be doing some 20-minute presentations, but there'll be time for some questions with everybody. Finish by 9:45. So again, if you want to have any one-on-one discussions or anything, let us know. And of course, a door prize at the end, which I think a lot of people have put their business cards in for development kits. But anyway, I'll hand over to Barry now. He's going to just introduce some of our speakers for today. Thank you.
Okay, good morning, guys. As you'll see, what we've tried to do is give a broad range of presentations today around the LPWAN space. So we've got 3 presentations for you today. The first one's going to be with Sierra Wireless, which is our module partner. The second one is with Thintrax, which is obviously the networks. Sorry, I did pronounce it wrong, didn't I? But you know what I mean. And the third one is with...
Nobody did it right, so don't worry.
I'll get your name right, you watch, you'll see. You'll be impressed. We know the French mafia is in town. And the third one is obviously Curling, who is a hardware provider too. So to kick off the morning, we're starting with Sierra. And no, I can't do it to you, can I? This is Tyrone. We have a bit of a thing going with our names. So Tyrone's going to do a 20-minute presentation on Sierra and their roadmap, I think. Is that correct?
I think so.
Excellent. I'll leave you to it.
Thanks, Barry. All right. Morning, everyone.
Morning, Tyrone.
Thank you.
Morning.
There we go. All right, guys. So thanks to M2M Connectivity for arranging this roadshow. We've already done the Melbourne leg, and I think it was quite productive, quite beneficial. And I would imagine that the majority of you guys in here have designed with cellular, or let's say wireless technologies. Cellular being probably the predominant technology over the last 10 to 15 years, 2G, 3G, etc., etc. So my role here today is just to get some clarity, or give some clarity around the cellular space, where we're moving into the LPWAN arena. So just a quick introduction. Sierra Wireless is a Canadian company. Our corporate head office is based in Vancouver, and locally we've got a couple of people within the OEM business unit. You've got Andrew Suttle, who's the VP for global distribution, and then on a day-to-day basis you've got Hassan, who's the regional sales manager in Australia and New Zealand. I'm the technical account manager for ANZ, and then in our enterprise solutions, we've got Ken McCrailed looking after the Airlink devices as such. Certainly, M2M connectivity is your point of reference for modules. They're quite knowledgeable and they've got a great specialist team down in Melbourne. All right, so let's take a step back now. Some of you guys may have seen this, especially the M2M guys. Don't give away the punchline, all right? So, what do you call a boomerang that doesn't come back? There we go. Right. I know it's an old joke, right? It sucks. But anyway, the point that I'm trying to make from this is that you can use a technology for a particular purpose, but it may not be the most efficient and most optimal technology for that, right? And that is where today's going to clarify. Whether you're using cellular in your application, whether you're using Sigfox, LoRaWAN, whatever the case, Bluetooth, Wi-Fi, it's about selecting the most efficient and best technology for your application, and we certainly recognise that. All right, so when we're looking at the wireless communication space, you've got your personal access networks, wireless LANs, cellular, and it is all about the speed of transmission as well as range that you're looking at. Now, LPWA starts to come into fairly low data throughput. I'm saying fairly low, up to 100 or 1 megabits per second, but you're looking at long range, and that is where all three of the technologies that we're going to be presenting today comes into play. So for LPWA, we identify it as low data rates, low data usage, and long distances for the 3 Cs. All right, so we're looking at coverage, consumption, and cost. So how do we, as Sierra Oneers, address that through cellular? Right, we want to get 5 to 10 times greater coverage from a traditional, and I'm saying traditional LTE point of view. I'm talking Cat 3, Cat 4, Cat 6 onwards. 100 times lower power, because if you're looking at a lot of the applications these days, it's demanding that you've got a 10, 15, 20, 30-year battery life in some applications. And then cost is certainly a huge factor. At the end of the day, we're all knowing that we're going to have these billions and billions of connected devices, and the only way we're going to achieve that is by having something that's at a really low price point to be able to drive that volume. All right. So when you consider Sierra Oneers, we follow the 3GPP specifications through 2G, 3G, and so on. At the moment, we've got Category M1 and NB1, which is essentially ratified, and then later on, through Release 14, we'll have Cat M2 and NB2 as well. Yes, it's on its way, right? Is that 5G? Don't go there, right? No, it's not 5G. All right, so we're within the license bands following the standards of the 3GPP spec. Now, within LPWA and cellular, you're looking at Cat-M, NB-IoT, and ECGSM. Right now, a lot of you may not have heard of ECGSM, and we're not going to focus on that. That is really an evolution of 2G. And given the carriers here locally aren't interested, and it's essentially an expensive technology, that's not something that we're going to be focusing on here locally. So today, it's going to be very much focusing on LTE Cat-M for the presentation. So the benefits that we see from cellular is that you've got a global service. It's infrastructure that's already deployed, it's available. And in a lot of cases, it's a matter of updating software of base stations and infrastructure that gives you access to these new technologies. Right, it's a durable investment because you've got someone that's taking care of that network for you, the Telstras and Vodafones, etc. of the world. And it's a trusted ecosystem. We know that security is a huge factor within these devices that are deployed across the globe. Now, how do we improve coverage with these new technologies? Now, yes, I'm the technical account manager. I'm not in R&D, right? So I don't know what all of this necessarily means, but you can ask me afterwards to follow up, right? So there's a couple of aspects where Cat-M, through the specifications, do provide you extended coverage, lower current consumption, and these presentations are going to be available afterwards. So I might be running through these things fairly quickly. What we've done is we've done a study and a summary, and what is the coverage performance that's expected? And essentially, it is about a 20 dB gain that we're after. So that means if you consider, for instance, Telstra, just because we're talking about coverage, and everyone knows that Telstra's coverage is the best geographically, they've got their next G network at the moment, based on 3G, and everyone's saying, right, we want 4G. Now, yes, Band 28 is going to give you that 4G coverage, but we're going to extend that. and that is inherent to the CAD-M technology that you're going to achieve that. Right, so how do we do that or put that in a graphical form? So from the left, your normal coverage offers or ends at about an MCL of about 145 or so dB. Through extended coverage mode A and B that gets offered through the technology within CAD-M, you're extending that right up to about 164 dBm MCL. Now, what does that mean? You've got a lot better coverage, but inherently through retries, yes, your throughput is going to go down, but the message is still going to get through. And that is how you're going to extend your coverage. So yes, you're going to have the carriers all saying, yes, we've got better coverage, blah, 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 right? But it's because of vendors like us that helps achieve those extended coverage, making them more numbers. Consumption. Within these new technologies, there are three parts that play into achieving better consumption for your end devices. PSM, which is the big buzzword at the moment. You've got optimization of the radio signaling, and then also flexible sleep through EDRX. All three of those are relevant within an offline scenario, and then you've got the center and the right-hand side, EDRX and radio signaling optimization that is relevant within an online scenario of the module. Today, the majority of the focus for me from a technical perspective is going to be PSM. Again, a lot of applications are going to be relevant when you're looking at CAD-M, where the device essentially is off. It wakes up once a day, once every 2 days, whatever the case is, and it needs to get a message out as quickly and as efficiently as possible. So if we take a look at what the traditional, let's say, instance is of transmitting data to the back end through cellular technology, you've got that timeline with your current consumption, and you've got various aspects. So you'll boot up your system acquisition, RRC Connect, etc., etc., etc. So everyone knows that low current consumption, and I'm talking really low current consumption, and cellular, those two are mutually exclusive up until now, right? How do we achieve that optimized figure? Well, quite simply, the first one, power PSM. So you, instead of being in a modem off scenario, you're now what we call PSM, power saving mode. It still means you're offline, but there are benefits in that state from a module point of view or a device point of view, as well as then the cellular network and the carrier's point of view. Right, so PSM, you can extend that through to about 410 plus days, and what we do is we take the registration and deregistration segments we take away. So now you're not worrying about registering and deregistering because both entities are aware of what the last state was. Secondly, optimize your radio signaling, reducing the time that's required, because again, both entities are aware of the state of the device and the carrier, and that means there's no overhead that's required, or much less overhead that's required. Then after your session has taken place, you can't really see that, can you? Down here, your DRX, that is the time that your module stays online in case there is information that is required back from the network, so you need to be contactable. Right. Currently, CDRX, taken as an example of about 2 milliamps, that is coming down to about 0.5 milliamp. So that is getting to 25% of what that figure used to be. And then probably one of the biggest contributing factors is booting up faster. Right. Reducing that time is a very, very big driver around reducing the current consumption that is required. So if we compare it side by side, you can see that there is a big change within the cellular technology. So while maintaining the same architecture and usage that you've been used to in cellular technology, but optimizing it for lower current consumption. All right, so 3 power saving techniques. PSM is the most relevant for us and most important. 87% of the signaling overhead requirements are reduced and optimized. And then, yeah, your implementation matters. And that has got a lot to do with the implementation that we as Sierra want us to do within the module in terms of boot up time. All right, so what my team has done, and this was about a year ago, they took a traditional scenario, so typical Cat 1, Cat 4 type module, take PSM into account, and they did a comparison. Right now, I'm not expecting you to read this. If you want, you can get up and get closer if you want. Right, but I doubt that you would. But what they've done is they've taken all the elements, they've tabulated it, and they've said, oh, right, so the red sections are what you get rid of within PSM, and that then brings it down to about a half. So that's 2000 milliamp seconds, and you're getting it down to about half of that with PSM. What does that mean? In an example up there, where you've got a 2500 milliamp hour battery, and with those specifications of TX and RX, yeah, if you're transmitting once every 24 hours, you're getting up to about a 19-year battery life that you can expect. All right, another use case, just an example, online scenario. So this is when we take into account other technologies, so the EDRX and also the radio signaling optimization. So this is an online scenario. Cat 1 is down here, so you're not really getting much out of it from a battery point and life point of view. Up to, let's say, a single message per day, you could expect about 15 years out of your battery, out of that scenario. Offline scenario, so you're talking PSM, you're getting 35 years plus. So that is essentially what you're looking at from a study that we've done in that type of a use case. So now the last C is cost. So how do we get these things to be a lot cheaper, right? Yes, volume plays a big role into it, but that's not enough. Traditionally, you need a lot of RAM in the module itself. We're cutting that down significantly for both Cat-M and then NB1, right? Your RF bandwidth cost, again, very high. We're reducing that significantly. Then the biggest component of that is integrating all these blocks on the right-hand side down to a single stage, and hence we can get smaller silicon, more complex, cheaper. Right. So where can you use Cat-M1 today? Right, that's actually quite visible. So the red part, so Australia, the US, is essentially where you're seeing Cat-M1 being live and active as we sit here today. All right. We're anticipating around about the first half next year, all the orange highlighted countries, they'll have their Cat-M networks ready, live and available. The other technology that is quite hot, a hot topic is NB1. Where do we sit today? Vodafone in Europe, sure, you've got NB1 live. That's pretty much where it ends today. And then, similarly, all the highlighted orange countries is what we expect by the first half of next year. So Telstra is planning on deploying NB1 as well as Vodafone, and those timelines are, let's say, fairly fluid. All right. So with Sierra Wireless, where do you go? We've got two ranges of modules. We've got our HL series, we've got our WP series. Thanks. HL series, in a nutshell, is your traditional bit pipe. And then your WP series offers you the ability to run your application, your host application on the module itself. That means you can take away your microcontroller, you can take away a lot of your external RAM because you've got those resources available on the WP series. The application development language we refer to as Legato. It is Linux based, it is based on the Yocto distribution, so it's not proprietary, it is something that's known within the industry. All right, so as I said, the HL series is where you want to be looking at. You've got the HL7749 that is available today. It is a great platform to start evaluating Cat-M operations on. Our next generation module will be available by, let's say, the first half of next year that you can deploy in mass production. All right, certainly speak to the M2M guys about product availability and timelines. Our WP series is what I've referred to as being our smart module. That is going to be available around about towards the end of the first quarter next year in commercial quantities for production, and that gives you access to both Cat-M as well as NB1 with onboard processing abilities. As I said, we've got our next generation essential module, our HL series, where we're looking at actually reducing the size of the module, but your footprint remains the same, whether you're designing today with a Cat4, Cat1, or the current Cat-M module. A little bit more reading material if you're after it, so certainly go online, take a look at the mango.io website. So one of the products that we've designed, we're not manufacturing, but they are available through M2M Connectivity, is what we call a Mango Red. It is a great platform for evaluating both WP as well as the HL series. If you're into the HL series and you're wanting a more elaborate development kit, they are available, and an example of that is outside for you to take a look at. And yeah, I think that's pretty much it from me. Any questions?